Deep in the constellation Libra, a subgiant star is moving rapidly through our galactic neighborhood. It is formally known as HD 140283, but it is more commonly called the Methuselah Star. Traveling at roughly 800,000 miles per hour relative to our solar system, its motion was first catalogued in 1912 by astronomer Walter Adams at the Mount Wilson Observatory. By the 1950s, spectroscopic analysis revealed a strange characteristic. The star was almost entirely deficient in heavy elements, a trait known as low metallicity. For a century, this fast-moving ancient object remained an outlier in star catalogs. But as measurement technology improved, it would present a chronological conflict that threatened the established rules of physics. In the year 2000, data from the Hipparcos satellite was used to calculate the star's age, based on its distance and luminosity. The result was 16 billion years. This creates a direct conflict with the cosmological limit. Data from the Planck satellite confirms that the Big Bang occurred exactly 13.8 billion years ago. A star cannot be older than the universe it resides in. In the scientific method, a paradox of this magnitude suggests our models are missing a vital component, or that the observational data contains a structural error. To find that error, astronomers use trigonometric parallax. Observing a star from opposite sides of Earth's orbit reveals its distance by a geometric shift. Distance is the primary variable here. If slightly off, our absolute luminosity calculation is wrong, and age is tied directly to brightness. In 2013, Howard Bond used the Hubble Space Telescope to secure a precise parallax measurement. He pinned the star's distance at exactly 190.1 light-years. This new distance helped, but the calculated age still hovered above 14 billion years. To close the gap, researchers had to look inside the star itself. Metallicity serves as a cosmic clock. Because the early universe was mostly hydrogen and helium, the oldest stars contain very little iron. Astrophysicist Don Vandenberg identified an anomaly. While the star's iron is low, it has an unusually high abundance of oxygen. Oxygen-rich stars burn hydrogen slightly faster. Accounting for this accelerated evolution lowered the star's calculated age to 14.46 billion years. Chemistry had narrowed the gap significantly, but with the universe's age fixed at 13.8 billion years, the discrepancy remained. This data profile from the 2013 Hubble study documents the star's specific metrics. The calculated age stands at 14.46 billion years, but the line below defines the resolution, a statistical margin of error of plus or minus 0.8 billion years. By subtracting that 0.8 billion year uncertainty from the primary estimate, the lower bound of the star's age reaches 13.66 billion years. That 13.66 figure fits comfortably within the 13.8 billion year limit of the universe. The paradox is resolved by respecting the mathematical overlap of statistical uncertainty rather than by breaking the laws of physics. Today, we understand HD 140283 to be one of the oldest known objects in existence, a halo star burning since the dawn of the cosmos. Its high velocity suggests it was born in an ancient dwarf galaxy that was eventually consumed by our own Milky Way billions of years ago. The resolution of this mystery highlights the self-correcting nature of science. When faced with a contradiction, astronomers didn't abandon their models, they sharpened their measurements. The Methuselah Star remains a living fossil, a pristine window into the immediate aftermath of the Big Bang. However, astrophysics is rarely settled. The Hubble tension suggests the universe may be expanding faster than we thought, which could indicate it is slightly younger, potentially reigniting the conflict. Meanwhile, the James Webb Space Telescope is searching for even older targets, the theoretical population 3 stars, which formed from pure hydrogen and helium with no heavy elements at all. Ongoing data from missions like Gaia will continue to refine these distance measurements, likely narrowing the margin of error to within a few million years. While the universe remains more complex than our current models suggest, each new measurement brings the history of the cosmos into clearer focus.